We have a rectangle, ABCD. Inside the rectangle, tucked against the left side, is a quarter circle, and attached below the rectangle is a semicircle. The line segment BQ is tangent to the semicircle, and we're told that BQ is exactly 9 units long. Our goal is to find the total area of the rectangle. Let's introduce a couple of variables. Let the radius of the quarter circle be A. Since the quarter circle fits perfectly inside the rectangle, the left side, AB, is A. Also, the bottom segment, BP, is A. Now let the radius of the semicircle be B. If its exact center is point O, then PO equals B, and OC also equals B. Now look at the entire bottom side of the rectangle, BC. It is made up of 3 pieces, BP plus PO plus OC. So the total length is A plus B plus B, which simplifies to A plus 2B. The area of the rectangle is simply AB times BC. So the area equals A times the quantity A plus 2B. Expanding that gives us A squared plus 2AB. Keep that expression in mind. Now for the first solution. Draw a line from the center of the semicircle, O, to the tangent point, Q. Since a radius is always perpendicular to a tangent, angle OQB is exactly 90 degrees. That gives us a right triangle, triangle BOQ. Let's identify its 3 sides. OQ is the radius of the semicircle, so its length is B. BQ is given as 9. And BO consists of BP plus PO, which is A plus B. Time for the Pythagorean theorem. 9 squared plus B squared equals the quantity A plus B squared. 9 squared is 81 plus B squared equals. Expanding the right side gives A squared plus 2AB plus B squared. Notice what happens next. There is a B squared on both sides of the equation. They cancel immediately. We're left with 81 equals A squared plus 2AB. But wait, that's exactly the area formula we saved earlier. So the area of the rectangle is simply 81 square units. Now let's solve it a completely different way. This one is even faster. We'll use the famous Tangent-Secant Theorem. It says the tangent length squared equals the outside part of the secant multiplied by the entire secant. In our figure, the tangent is BQ. The secant runs from B to C. The outside portion is BP, which has length A, and the entire secant BC is A plus 2B. So the theorem gives us BQ squared equals BP times BC. Substitute the values. 9 squared equals A times the quantity A plus 2B. Once again, 81 equals A squared plus 2AB. And that's exactly the area of the rectangle. So our final answer is 81 square units. If you found one of these methods before I did, let me know in the comments. And don't forget to like the video, subscribe, and I'll see you in the next one.